Hi, it's Miss Temez, and I am working on lesson 1-6 today. Let me adjust that. Special functions. So today's a little difficult, but the more practice you do is the better. And also the part that's going to be on the test are domain and range, I believe. So let's get started. So today's focus are piecewise functions, which are different segments that make up a function. A step function is the most popular, and remember, we may have an open dot, closed dot, open dot, closed dot, open dot, closed dot. And it looks like a bunch of steps. Now, if I drew a vertical line, it only goes through the closed dot. So it still is a function because this open dot means it doesn't exist right there. So there's not two dots. Greatest integer function, you just need to know this symbol means the greatest integer. We aren't going to test you on this, but if you see it somewhere, it just means an integer that is in that set. So if I have 2.5, the greatest integer there is 2. Okay, absolute value function. This is the absolute value function. Actually, it's not that narrow, it's a little wider. And that is a parent function. Parent functions go through 0, 0, like a line with a positive slope, y equals x, or like x squared with no transformations. This is y equals x squared. And there are no transformations with a parent function. And we'll be doing more of that in lesson 7. So let's just jump into it. Here's graph a piecewise function. There are two parts. We have this and this. They are both linear parts because I have x minus 3. And we know y equals x minus 3 has a slope of 1 and a y-intercept of 3. Then we also have y equals 2x. Now there's nothing there for b, so b is 0 and your slope is 2. So I'm going to show you different ways to do it. They've already completed it. Let me move this out of the way. So we have again y equals x minus 3 when x is less than or equal to 1, and y equals 2x when x is greater than 1. This is a solid dot. This is an open dot. So this one right here is 2x, and this part right here is x minus 3. Let me show you how to graph them. We're going to start with x minus 3. We want it where x is less than or equal to 1. So it's going to exist from here to the left. So everywhere that this graph is there. Several ways you could do it. You could, sorry I forgot to grab a ruler. You could graph your y-intercept's -3. Your slope is 1, so you could go up 1 over 1, up 1 over 1. But we really want this way. So if you did that, up 1 over 1, you want it from 1 left. So there's that portion. You could also plug in 1 because that's our restriction, and I'm going to use this part over here on the right. So y equals, I'm going to plug in 1 for x. So y equals -2. So you could go to 1, -2, the point. This is x and y. 1, -2, start there. Since this is a line, the slope is consistent throughout the line. For a slope of 1, you could do m is 1, so I could do up 1 to the right 1, positive, positive, or you could do down 1 to the left 1. So you could start here and go down and left, down and left, down and left. That's the second way you could do it. So you could try to graph it and then just go from lesson 1, or you could plug in the value, find out where it starts, and then do your slope from that point. Or you can, this one goes to -3. I'll show you the third way with the 2x, because 2x is not starting at 0. So I reused all this for that equation, let's go to the 2x. So y equals 2x starts on 0, has a slope of 2. So I start on 0, but this is greater than 1, so I just want from here to the right. So I don't want to connect here, but you can put the dots. 0, slope of 2 is rise 2, run 1, up 2, right 1, up 2, right 1. Now, I know I want greater than this line, so I'm not going to draw this part of it, and it's an open dot because it is greater than 1. So you just draw that part of it with the open dot. That's the other way you could do it. Try to figure out, use your intercepts, not your intercepts, but where your slope crosses the grid, and then just draw the part that we want. We want just this part, so you draw to the right. So we're going to do several today, so hopefully you get the hang of it. So here on the check, we have 3 segments that we'll be graphing. So we could do domain and range after we graph them. So our first segment is when x is less than or equals 0, so it's y equals 2/3 x. I'm going to write plus 0 so we know our y-intercept is 0. Then our next one is y equals 3, which is a horizontal line. And then our last one is y equals negative 2x plus 5. So our segments on our x-axis are going to be right here from 1 to 3, 1, 2, 3, and then greater than or equal to 4. And for this one, we're going to have a closed dot. These two, the ends are going to be closed dot, and this is going to be a closed dot. So let's do the easy one first, horizontal line at 3. So horizontal line at 3, 1, 2, 3, goes along here, but we only want it from 1 to 3. So I'm just going to put a closed dot to 3. There's the easy one, done. Okay, that's that segment. Now let's do this segment. This segment is to the left. So I know my y-intercept is 0. Now 2/3. We could go rise 2, run 3, up 2, right 3, but that's going to be over here. We need to be on this left side of the graph. So I'm going to do a negative 2 over negative 3, which is down 2, left 3. Negative divided by negative is a positive. I'm still going to get a positive slope on this line, but it's just going to be this section right here. So there's that one. Now let's do this one, which is a little tricky because it's way over here on the right. And it's this equation, which has a y-intercept of 5. So for this one, since it's so far from the y-intercept of 5, I'm going to plug in and then do my slope. I'm going to plug in 4. So y equals negative 2 times 4, because it's greater than or equal to 4, plus 5. Negative 8 plus 5, which is negative 3. So I could put a point on 4, sorry, not 2, 4, negative 3. So here's 4, and I go 1, 2, 3. There's my point. And we have solid dots, so that's a solid dot. Now from that point, my slope is negative 2. So from that point, I'm going to do down 2, right 1, down 2, right 1, and just draw my line. The reason I did that is because it's so far from the y-intercept. You could also start on 5, which I think is there, 1, 2, 3, 4, 5. And you could go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, and then start drawing it here because that's where it is. All right, let's go on. Example 2. So with the videos again, you could fast forward, you could rewind, you could watch it slow, you could watch it fast. You could adjust how you watch these. So this is $88 when you get 5 or fewer jerseys. The football coach is buying jerseys. $75 for 6 to 11, $65 for 12 to 29, and $56 30 or more. So we have to write our restrictions. So we know till 5. So after 5, we know we're not going to do decimals, so we can't say 5 or greater. We're going to do 6 to 11, and then we're going to do 12 to 29, and then we're going to do greater than 29. Oh, I didn't do domain on range in the last one. We'll do it next. We'll do it on the next one. Okay, so how much would it cost to buy 11 jerseys? 11 jerseys is right there. So we get 75x. So 75 times 11, and we get, I think, 8. Oh, I don't remember. 825. How many for 25? 25 is in this range. So we get 65 times 25, and we get 1625. The last one is written a little differently, although it's asking the same thing. So we know f of x, I'm going to look at 29 because that's what they're using, 29, is 65x. So where the x is, this one is asking what's f of 29. So that's where the x is. So we're going to do 65 times 29. And I think I know this one. 18. Yep. 1885. Okay, so you don't have to do a graph for this one. You're just writing out the amounts. This is like number 5 in your assignment. Okay, so now let's look at some step functions. This is a special type of piecewise function. Before I go on to greatest integer, I want to look at this one. And this is, they're saying, why is the range not expressed here? So let's talk about domain and range with this graph right here. Domain, since this is a solid dot, it goes from here. This is a solid dot, includes that. This is a solid dot, includes that, goes all the way here. Your domain is from -4 to 4. But your range are just 3 numbers. Your y values, and this is different. This is saying it's going from -3. It's not, because they're not connected vertically. You got this y, you got this y, and you got this y. So your range is -3, -1, and 3. That's it. Those are your range values, and that is something that will be on the test. Greatest integer function. I've been doing this today, and I'm a little confused. I should have watched something on it before I did it. I can't explain this. So let's look. You're not just rounding up or down. You're looking at the greatest integer that's less or equal to x. So 10 is between, here's a number line. Here's 9, here's 10, here's 11. 10 is over here. So the greatest integer for 10.7 is 10. 10.7 is right there, sorry. The greatest integer is 10. Now when I do -6, I'm just drawing number lines. -6.35 is like right here. So they want a number less, an integer less than or equal to. So for that, it's -7. And then for 5, it's just 5 because that's an integer. So 5 is that value. The graph looks like a step function. It is a step function. So if you see a graph or you see this, it's a step function. Okay, postal rates. The cost of mailing a letter was 47 cents, not over an ounce. Oh, this is 2016. I thought our book was newer. 68, not over 2 ounces. 89 cents, not over 3, and $1.10 up to 3.54 ounces. So let's look at this before we do the graph. We're going to have an open dot on the left side because these are not equal to. We're going to have closed dots on the right side. It's going to be a step function because y are these 4 values only. So our domain is from 0, because it's an open dot, to 3.54. But our range is 47 cents, 68 cents, 89 cents, and $1.10. Okay, those 4 values are our range. Now let's graph it. So from 0 to 1, it's at 47 cents. So this is 0.6. So 47 may be like right here. 1 to 2, it's 68. So that's above 60. 2 to 3 is 89. This is 8. So this is 89 for me. And then $1.10 from 3 to 3.54. $1.10. This is $1, so this is $1.10. So that one doesn't go to the next line. It just stops right there about 3.54 because this is 3.5 and just a little over that. So that is that step function for this table. Let's do another step function for figuring cost and the number of hours. But first, let's talk about domain and range. Domain is parentheses at 0 up to 50. Or you could put 0 less than x less than or equal to 50. Either one of these is correct. And our range are just these 4 values, 500, 1400, 2500, and 4000. So I'm just going to have 4 segments on this graph. From 0 to 5, I'm going to be at 500. Remember, we have an open dot and a closed dot. So open dot, closed dot. 5 to 15 is 1400. So that's about right there. Closed dot. 15 to 30, 2500. Open dot. 30 is right there. And then 30 to 50, 4000. Open dot. 50 is right here. There's that one. Okay, so that's the graph. Not doing greatest integer function. Let's jump now to absolute value. So this is the parent. It goes through 0, 0. This is the function. There's no extra numbers in the function. Now, if you have a parent, or you become a parent when you have a child. Here is a child. See, it has these 2 extra numbers in there. I'm going to graph the parent just so you could see a difference, the changes with the child. So, this is the parent. How did this child move? Well, this child moved up 3, 1, 2, 3, and that is from this part right here. So if you have a number outside to the right, if it's positive, it's moving up. If it's negative, it's moving down. We're going to do more of this next lesson, lesson 1.7. Now, I don't know if you could tell, but this one is wider than the original. And what makes it wider is this 3/4. So what that's called a vertical compress or vertical shrink. So this is the regular one, but I'm 3/4 as tall now. So when something is a height and then is 3/4 as high, it's going to get wider. If this number is less than 1, it gets wider. If this number is more than 1, so if this is the height and now I'm going to be 2 tall, 2, the number 2 times x, I'm going to be a vertical stretch. And when you stretch vertical instead of shrink, it gets more narrow. But we'll be doing more of that next time. This one's a little different because we did move 1, 2, 3, but it also has this, which is not multiplying. This is subtracting, and we'll do it more. This is what would make this 0. X equals 1 would make that 0. So 1 is positive, so it's going to move it over here to the right. And then it didn't shrink or stretch because there's no numbers multiplying by it, but it moved up 3 to the right 1. I know it's a little tricky because it says -1, but when it's inside a symbol, it's opposite. It's what makes this a 0. So 1 would make that a 0, so it's to the right. But we'll do more of those in 7. We're going to have even an extra worksheet in 7 to practice transformations. Okay, so your assignment for 1-6 is on page 53, and it is numbers 1 through 5. You only have to graph 1 through 4. 42 and 43, you've got to tell me what equations are used to make those piecewise functions. Let me know if you have questions. Thanks.